Hey, this is Math 8, Unit 6, Lesson 8, Analyzing Bivariate Data. Alright, so it says speed versus step length. A researcher found an association between a dog's stride length and its speed. So he found an association, that means there's a connection between the length of how far a dog strides, meaning how long is its step, and its speed. The longer a dog steps, the faster it goes. The predicted speed in meters per second, S, as a function of the step length in meters, L, is here. Okay, so the predicted speed as a function of the step is going to be here. So this is S as a function of L. Okay, what does the rate of change of the function, okay, so it's a function of this is our function, tell you about the association between the stride length and speed? Well, our rate of change is going to be right here. In an equation, often we call that a slope, but this is our rate of change. Our rate of change is 4. That is our rate of change here in this function or this equation. So what does this 4 mean? Well, the 4 means that for every 1 meter of length increase in the dog's stride or steps, dog steps, there is a 4 meter per second increase in the dog's speed. Okay, so every time the length goes up by 1, whatever that 1 is, we're going to multiply it by 4, right? We're multiplying by 4. That's our rate. It's positive. So it's going to be an increase going up. And that's what times 4 means. So we're going to increase the speed, multiply speed 4 times more than what it was for every length of the dog's step, a stride length that increases there. Okay? So that's what we have for that first one. Alright, let's take a look at activity number 2 on animal brains. Hello, Stevie G. Here are animal brains. Well, not exactly that. Whoa, hello. Cat coming in there. Oh my goodness. Oh, Stevie G. You must love doing math problems, somebody. Sorry about that. That's what happens when your cat attacks your work area. Okay, alright. It says, is there an association between the weight of an animal's body and the weight of an animal's brain? Is there a connection between the brain and body weight of an animal there? And so we have all this data here in this table. So the question is, all this data, is there a connection between all of this information? Okay, that's what we're wondering there. So it says use the data in the table to make a scatter plot. So we want to use these numbers to make a scatter plot and see if there are any outliers in the information that we have. Okay, so I'm going to turn it over here and I have my scatter plot here. Now what I have beside me, instead of flipping back and forth, is I'm going to use this table right here and I'm going to read off these in order and then plot the points over here as I read them off. So the cow is at 465 for the weight, which is right about here, and 423. So there's my cow. Then I have a gray wolf, which is 36, which is here, and 120, so a little more than 100, right about there. The goat is 28 and 115, so a little less. And there's the goat. The donkey is 187 and 419, so here is 187. Oh, I gotta remember this is 50. So 187, which is about here, and 419, which is there. Be careful about these little squares because these are counting up by 50, and these ones are going this way are counting up by 100. So just keep that in mind. That sometimes when they make their graphs or their grids, it's not proportional there. Okay, so it's not kind of even numbers there. The horse is 521. So here is 521. This is 550, so 521 is here, and 655. So we go about there. monkey is 10 and 115, so 10's over here and 115 it's going to be here. The cat is 3 and 26, which explains why Stevie G just jumped in front of the movie just now. Giraffe 529 and 680, so 529 and 680, about the same as that one, maybe a little bit more. Gorilla 207 and 406, so 207 here and 406 here. Human 62 and 1,320. Well, that's going to be up there. We'd call that an outlier so far, right? Another kind of monkey is 7, 179. So 7, 179. Kangaroo 35, 56. Sheep 56 and 175. And jaguar 100 and 157. Chimpanzee 52 and 440. And a pig 192 and 180. Alrighty. So those are all the data points plotted in this scatter plot there. The first question says, after removing the outliers, does there appear to be an association between body weight and brain weight? So our outlier would be this guy right there for sure. That's definitely an outlier there. Okay. Another outlier, you might want to even say that the chimpanzee one is over here. This was our human, and here was our chimpanzee over there. I mean, and so if there's an association, can we draw a line through there? And I would say, yeah, I could probably draw a line through there and say there seems to be an association, and it seems to be a positive association between body weight and brain weight of the animals and of course the human inside of that table we were looking at there. Okay. We have a couple exceptions, a couple outliers that don't really quite work out there, but it seems to be that the more body weight increases, the more brain weight also increases in the different animals there. Okay. Then it says, using a piece of pasta and a straight edge, fit a line to your scatter plot, estimate its slope. So we already did that right there. That's our little scatter plot and our slope. If we were to estimate that out, I could kind of find a point from here to here. Looks like I made a point between two grid lines just by coincidence, and I know I'm going up 100, so I'm going up 100, and I'm going over, in this case here, 50, 100, I'm going over 100, so we'd have a slope of about 1, which means, what does this mean for us? It means that for every 1 kilogram increase in body weight will result in a 1 gram increase in brain weight. So every time I go up 1 kilogram in body weight, I am generally going to go up 1 gram in brain weight. And I got that from the kilogram and the gram right there. Okay, and that's it. So the third question on the next page says, does the fitted line help you identify more outliers? So if I use this as a line of fit, are there more outliers? Perhaps. We might say that maybe that's an outlier. It seems to be pretty far below the line. You might say that these guys here maybe are outliers, a little bit more, above the line there. But most are pretty close there. That line of fits, again, if you draw that hot dog bun we talked about before, do you have ones that just don't quite fit in the bun? Probably a couple. Alright, so but again, it's up to you what makes the most sense. Okay, and turn the page here and skip the Are You Ready for More? And I'm going to go to activity 3 just real quick just to talk this through. It says, earlier in class, you gathered data on height and arm span. Now that was back in lesson 2, activity number 2. So you need to kind of look back in your book in order to do this activity. So this is the activity. When I did it by myself at home, so I didn't have a lot of friends to measure their arm length and hand span, or height and arm span, I should say. So you should have some data from your class. Sometimes a person's arm span is the same as their height, meaning that if I have a person here and they stretch out their arms, that's kind of crazy, that the length from here to here ends up being the same as here to here. That this length matches that length if you're to measure that. The question is this true for anyone in the class? Now the way you'd find that out would be if they happen to be, for example, 50 inches tall and their arm span was 50 inches across. Then you'd find someone that is absolutely true for. It wants you to make a scatter plot for the arm span and height data from lesson 2 activity 2 and describe any association that you see. So you would make a scatter plot like so, and you'd probably have, based upon your data, your height here. I think you did in centimeters, and over here you'd have your arm span in centimeters, and you could then figure out what size you want this to be, and you're going to plot your different points that you find, and you'll probably find some sort of line that looks like this. I'm totally making up those dots, right? Because I don't have lesson 2 activity 2 data, but you do. So the question then is the line y equals x a good fit for the data? Meaning that if y is 1, x is 1. Well, so like a 1-to-1. Is that true? You need to find a data point. Let's say again that Johnny was 51 centimeters tall and had an arm span of 50 centimeter arm span. Okay, is that a 1-to-1 ratio, right? Does y equal x? Would you say 51 equals 50? Well, we wouldn't, but is it close is the idea here. When you're dealing with data like this, the question is, good fit's not about perfect, is it close? We would say, yeah, that's pretty close. So can you find some values in your chart that are pretty close to that line of fit? Probably. And the next question, it says, examine the scatter plot. Which person in your class has the largest ratio between their arm span and their height? Largest ratio, what does that mean? That means that they are the furthest from the line of fit, right? Because let's say I had a height of 50 and an arm span of 20. Well, that ratio here, 50 to 20, is just not what I was looking for, right? That's a 5-to-2 ratio. Whereas before over here, I was a 1-to-1 ratio. This ratio and this ratio are not the same. So the person that seems to be the furthest from the line, if you had an outlier, someone that was maybe really tall but had very short arms, would look something like that. Or you had someone short with long arms, maybe they'd be over there. Okay, you could have those things. So is there someone in your class that has the largest ratio? Who is that and what is that? Okay. And again, remember, you're in junior high, so you're all still growing. So come back and try this again in 10 years and see what it comes out to be. All right, so in summary, people often collect data in 2 variables to investigate possible associations between 2 numerical variables and use connections that they find to predict more values of the variables. So data collection is usually 2 variables to help us find its possible associations and do some predictions. All right. Typically, the steps are you collect some data, you organize it and represent it, you look for the association. If you have any outliers, you try to explain why they're there, and then you find a function that fits the data well. Okay, that's that equation we kind of talked about there. What makes it work the way it does and makes it work for everything else that allows you to predict more. That's what the function really helps you do, predict more. All right. So that's it for today's lesson. I'm going to give you some time to work on your homework, and we'll come back and check it off together in just a few minutes. All right, homework time. Different stores across the country sell a book for different prices. The table shows the price of the book in dollars and the number of books sold at that price. Okay, so we have the price in dollars and the number sold. And the data is all scrambled here for both columns, so it's not very useful for us in that regard there. So 1 says 2 as our first activity. It says draw a scatter plot of the data, scatter plot, and label it, and then look for any outliers and explain why you think they're outliers. And then we're looking for a relationship between them, if we can, and then remove the outliers, and then draw a line of fit for the data. Okay, so let's take a look here. I'll make a little chart. like so. Okay, and we can kind of chart this out as maybe 6, 8, 10, and 12 for my price in dollars, because the price seems to go anywhere from about $7.99 all the way up to $12.10. So I should get those numbers there. In terms of the numbers sold, I can see I have a 30 over there all the way to 130. So we could count up in this case here. We can count by 40, 80, 120, 160. Okay, and that's a pretty big gap there. You could choose something different. You could choose counting by 20s, counting by 30s, counting by 10s even. Not a big deal. So let's plot these points here. What do we have? We have $11 and then 53. So 11's about here and 53 is about here. We have 10, 50, and 60. So 10, 50, and 60. Somewhere about here. 60 is more than 53, so a little higher. We have 12, 10, and 30. 12, 10, and 30. So 30 is going to be about here. 845 and 80. 845 and 81. 925, 70. 925, 70. 975, 80. 975, 80. 725, 120. 725, 120. 12 and 37, so here's 12 and 37. 999 and 130. It's up here. And then about $8 and 100. $8 and 100. 875 and 90. Okay. So there's our scatter plot, and we labeled it with the price in dollars, and this over here would be the number sold on that side there. There's our lovely, lovely scatter plot, something like that. Are there outliers? We would say, yep, that seems to be an outlier right there. This one that is at, what is that, 10 and 130. So this one seems to be an outlier right there for whatever reason, okay? And why is it an outlier? It's just not near the rest of the numbers. The rest of the data points. It doesn't make sense. It's way over there. That's why it's an outlier. Is there a relationship between the variables? Yes. Now you need to explain this here. As the price increases, we can see the number of books decreases. Right? That's a relationship. As the price of the book decreases, the number of books sold, as the price increases, the number of books sold decreases. So you sell far less of the books at the $12, but if you made it $7, you can sell a lot more books. Okay, which is good to know. You could probably do some math there to figure out is that a good idea. So think about this. If I had a $12 book and I sold 30, how much money am I making? 30 times 12, we have 0, 6, and we have 360. But if I sell this $7 book, and I have 120, let's just round it to 7 and 120, then how much money do I make? I make $840. So while that's a more expensive book, I sell far less. This is cheaper, I sell a lot more, and I make more money. So this is why this is important information. The more expensive a book is, the fewer I'm going to sell. So if you want to make the most money, then sell it for less, and then you can sell more and make more money. You learn that there. Remove the outliers and draw a line. So not looking at that one, we could draw a line something like this, right? And is that a good fit for the data? Yes, it is. And it would show that there's that negative association. No problem at all. Let's look at number 2. Here's a scatter plot. Lovely. Here's our scatter plot. We see it goes up and then flattens out. All right. Is this linear when it goes up and like that? No, which means it's non-linear. Is it positive? Meaning, is it going as this increases, that increases? Yeah, it's definitely positive. This doesn't do much, but it's still, as that increases, it's a positive thing there. So we would say it's positive, right? I'm not really in agreement because of just this part is just weird. So it's not a great positive example, but it is mostly positive, especially this first part there. It's certainly not negative. And there definitely seems to be some sort of association, at least for this first part. And then once you hit 30 weeks, not a lot of changes. Okay? And number 3, using the data in the scatter plot, what can you tell about the slope of a good model? So if I had this data and I drew a line of fit, what would you say about the slope of that model there? Is the slope positive? Nope. The slope 0, because again, positive is going to be what? Going up. The slope is 0, what's that look like? Just flat. And nope. A slope negative? Yes, indeed. The slope is negative. There is one more answer choice on the back side, which is there is no association. That would be all random stuff. But this seems to have a slope, seems to have a negative association, and we're good with that. All right, that is it for today. Have a great day. We'll see you next time.